Mamma salut les amis et bienvenue dans cette nouvelle vidéo. Today we are going to solve an exercise under GCE 2020 Circuit Analysis exercise number 1. The first question was to determine the voltage VAB and VCB in the circuit below. We discovered that on this circuit, let me take the right pen. I'm going to take the white one. Let us consider the following circuit. We discover on this diagram that the current flowing through the circuit, let's say it is I, is the same current flowing through R1 as well as R2. Okay, as we set it so, we can discover that the voltage across the cross, if the current is going down, means that the voltage will be going up, and it is the same current going like that, means that the voltage at this point, as you can take it like that, it depends, you can still change the direction. Let's say the current is going like that from the higher potential to lower potential, and if the current is going like that, the voltage across this point will be like that, as well as the voltage at this point will be like that. We can simply write the equation below. V, the current flowing through resistor R2 is equal to VA minus VB all over R2 will be the same current flowing through the resistor R1, which is equal to VB minus VC all over R1, which is also equal to the main current flowing through the two resistors, which is equal to VA, which is here, VA minus VC all over the sum of the total resistor, which is equal to VA minus VC all over the sum of the two resistors is equal to R1 plus R2. Now we can arrange this expression very well. We discover that VA minus VB is only equal to VAB on R2, which is equal to VBC on R1, which is also equal to VAC on R1 plus R2. And according to this diagram, we discover that VA minus VC, which is also equal to VAC, is equal to 35 minus negative 19 volt. So we can simply write this equation like this. VA, this pen is not showing very well, I'm going to continue with the white one. VAC is equal to 35 volt minus negative 19 volt. When you apply this equation, you're going to give a 54 volt. Means that the voltage, the supply voltage, the voltage difference between this point as well as this point here is equal to 54 volt. Means that it look like we connect a battery source of 54 volt across these two terminals. And if you have it like that, we can, from these two equations, we can combine it and carry out the expression of VBC as well as the expression of VAB. What was the equation that was asking above? Let us go down and see how you can evaluate it very well. We are going to consider, first of all, this two equation. Let's say this one. I'm going to consider this equation in order to carry out the expression of VBC. Means that from that equation we discover that VBC is also equal to produit des extrêmes égal au produit des moyens will be equal to R1 all over R1 plus R2 multiplied by the supply voltage, which is equal to VAC, which is the voltage that we evaluate before. As well as if you consider both, if this item is also equal to this item, we can still continue like that. Let me divide like that. Means that VAB is equal to R2 on R1 plus R2 multiplied by the supply voltage, which is equal to VAC. And if you look it very well, you discover that this is the application of voltage divider. This is an application of voltage divider. That is all. So we are going to apply these two formula in order to get the expression that was given. And the expression that was given for us was VCB, as here we calculate, but VBC. Means that from that equation, VCB is equal to negative VBC. Take note for this equation. This is for mathematician. There is nothing to speculate on this formula. That is all. We are going to apply this formula and get the value of all the voltages VAB as well as VCB. Here we have both the two resistors, 24 and 20 volt. Means that if you apply it very well, VBC will be equal to 25, and VBC is equal to R1. R1 is equal to 20. 20 divided by 20 plus 25 multiplied by 54 volt, and VCB will be equal to negative 25 over 20 plus 25 multiplied by 54 volt. That is the expression that was asking, and we can evaluate it and in order and get the expression of the value of all that voltages. I don't have the calculator with me. Let me open the calculator and get the result. I hope that you will be able to apply that value, the value of that expression. That is all for that exercise. If you have the question, don't forget to ask in the description section below. And if you are the new in this channel, don't forget to subscribe and like, share, comment, and be okay. If you have any question, don't forget to ask. And Happy New Year for the new academic year 2021. Ciao.